Alright, I'm back online, ready for the next chapter of Hans's book. We're going to be doing some exciting things today with stream catchment delineation, which is something I've been looking forward to getting in the book. Yesterday we kind of wrapped up the chapter on doing like a multi-criteria analysis. We had this little scene here. I went and made it into a 3D scene as well, just for fun. And it was pretty straightforward. I got some gotchas, but it was more just with not the concepts, but more just getting QGIS to always do exactly what I wanted to do, and not realizing when I had made a mistake or something. I'll be watching in the live chat if anyone wants to say hi or give me advice while I'm going. It would be great. We're going to start from chapter 4. Here we go. So I'm just going to save that project and close it and rearrange my user interface a little bit here. So we start off with chapter 4. It's saying that one of the most important uses of GIS in hydrology is the delineation of streams and catchments. And in this chapter we're going to look at some generic workflows for doing that. We're going to be using the Srtm plugin. I already have that plugin had it configured. Let me see if I've still got it running here. Srtm, yeah. So this plugin here is a really valuable, useful plugin by good friend Horst Duster from SourcePol, and it allows you to download a bunch of Srtm tiles easily in one go, but you do need to have a password and so on. I'm sure the book will cover that as we get to it. And then to start off, he describes the general workflow, which is quite interesting to just go over. So we're going to start with the DEM. We're going to maybe reproject the DEM. We're going to mosaic the DEM. We're going to clip the DEM. So that's basically just preparing the terrain model for the study area. I might deviate a little bit from the script and do it for my own area. That might be fun. I just don't know if it will delineate the catchment boundary, so we'll have to see what they've got in mind for us. And then they cover interpolating any holes or sinks in the DEM, and also taking spikes out. And then calculating the flow direction for each cell and deriving the drainage network. So that should all be fun stuff. Alright. Alright, and he's talking a little bit about using when you have an existing stream network, you can actually sort of burn it in. He calls it, I think in tins they used to call them, what do they call them? I can't remember the name, but yeah, you can set cut lines, I think they call them. Alright, and he says the data can be downloaded from the Locate Press website, but I think we've already got the data we need. Let's have a look further. So I'm just trying to see, so he's going through the installation of the Srtm downloader and looking at the coordinate reference system and map units of one of those tiles. I'm just trying to see if I can cheat and do it for my own area. So what I want to do is I'm just going to read ahead a little bit in the book to see, or actually I can look at the sample data to see, does he provide a catchment boundary already. So we're in chapter 4. we've got some height and we've got a bounding box. So I think he's actually going to delineate the catchment boundary as well, which would be great. So I'm just flipping through because I want to try to prevent that I paint myself into a corner if I haven't, if I've chosen to do it with my own data, and then it creates a problem. Right, so I'm just looking at him clipping things and styling it, changing the blend mode, putting sinks. Okay, so I think I can just go ahead and do it for my own area. I'm going to try it and see if I run into problems. So I know that in this data directory he's got a bounding box here, and then he's got some elevation. So I'm going to create my own bounding box, but I'm first going to just drop in the OpenStreetMap dataset and sort of zoom into the area where I live here in Portugal. I don't know how big the catchment is, but I'm going to just do maybe something like that, and let's see how that works. So I'm going to go here, and then you're going to use the plugin Srtm downloader, and I'm going to grab the data for this area here, and I'm going to put the data into that same folder here. Okay, and then we're going to hit download. There's only one image. Okay, so it will ask you for some credentials. I've already got mine set up. You'll need to go create an account if you don't have already credentials. So in the book he says we should have a look and see what coordinate reference system the data set is in, and if we find that it's in geographic which it is, we're going to want to reproject it. So I could use the local Portuguese coordinate reference system, or I think for this case I'm just going to use EPSG 3857. It's probably not the best choice to make ever, but it'll be kind of practical to use for now. So I'm going to go Raster Reproject here. There's different ways you can do this. There's just one way to do it. We set the source to 4326, the destination to 3857. I'll take pretty much the defaults there, and then why not use a multi-threaded one? That sounds like fun. And then we're going to save that into that same folder. So we're going to call this Innovation 3857. Alright, okay, and we're going to run this, and we should get ourselves a new layer, which when we look in the layer properties here, we should see that it is now in our 3857 coordinate reference system, which is great. And I'm going to just get rid of this old layer so I don't confuse myself later. And I'm also going to save my project quickly, just so that I've got something to fall back to if I have a crash. Okay, so okay, so that's getting the elevation data, and then I think he's going to get us to he walks through building a VRT, a virtual raster, which is useful if you've got multiple tiles. In my case I only got one tile, So I'm going to skip that. I'm pretty familiar with the process of doing that already. But if I had more than one Srtm tile, I certainly would have done that as well. Now, the next question, okay, and then he's talking about reprojecting the DEM, which I've done. And then he's talking about creating a subset of the DEM. And I wanted to bring up my system performance monitor while we're working here, so that we can have a look and see when things are chewing up a lot of CPU time. But I've got, as you can see on my computer here, I've got a pretty powerful machine. I'm not too worried about subsetting it, so I'm going to skip the clip the raster by mask layer steps, which I do understand how to do. Normally you can go and shrink it down a bit if you want to. I just don't know where the catchment boundaries are in my area, so I don't know if I don't want to go and lop off on the edge of the catchment boundary. Okay, and then he's talking about styling the DEM, and we're using CPT styler, CPT city styles, which is something we did the other day as well. There's some fantastic gradients and things in here. Oops, the wrong one. We'll go look in the elevation ones here. See which one he wants us to use. Okay, he's suggesting CDA and SDA. Let's try that one. Alright, and so we've got some nice looking cartography there. I think we're going to create a little a copy of the layer, and then we're going to create some fill shade effect behind it. So again, there's a few different ways to do this. This is something I really enjoy doing as well. So I'm going to just duplicate the layer. This copy I'm going to set as hill shade, and we can use the multiply for the rendering to sort of make the other one come through the bottom, something like that. And yeah, and we've got some nice looking elevation. We can see that there's a river running through here. So this is part of, let me see, this is the Tejo River, which is a huge big river, runs all the way through Portugal, all the way down to here. So I'm not going to try to delineate the catchment for that, because what I'm actually interested in is like the sub-catchment around here, around Castelo de Vide, Port Alegre, and so on, this area here. But it is interesting to see the tributaries actually come quite close to my area, which you can see more nicely on the elevation map than you can see on the rivers from OpenStreetMap, for example. Okay, so we played around with blending modes, and so he's just getting us a pretty looking map. And I've gone a little bit off script from what Hans has proposed to do, but I think that's fine. So now we get on to the exciting part. Now we're going to do fill the sinks and calculate flow direction. And to do that, we're going to need to use PC Raster, and to do that, I might have to jump through a few hoops, because I don't know if my PC Raster is working out the box. I do believe that PC Raster QGIS, I believe that they made some improvements to the way that the plugin could be set up, so that it works quite nicely under Ubuntu. So I'm just going to go and have a look here, and have a look and see. So there's Windows, and there's Linux, Mac OS, and so on. Okay, so their approach uses Conda Forge. Or, okay, this is from me. You can build PC Raster on Linux as well from source. So, but somebody's modified that for Linux. Yes. Okay, I'm going to follow these instructions. Just going to open a terminal here. Put a new window, new tab. Right. And then we'll just follow these instructions quickly. So this is a little bit of a diversion just to get PC Raster installed. Okay, it's going to install a bunch of stuff. And then we're going to clone PC Raster into a repository on our disk here. I'll actually do that in parallel. I already have it checked out, so I'm just going to freshen my checkout here. I might have done this already, but anyway, I'm going to do it again just to be sure, because I can't remember if I set it up on this machine or not. And then we can go into here. There's a lot of updates since I last worked on it, so let's see if I made a build directory. Yep. And then I'm going to run this here. But I'll just wait for these dependencies. Okay, some of them didn't arrive too nicely. There seem to be a bunch of these repos that are offline or something like that. I'll just do an update. If you're on Windows, there's separate workflow. Maybe a bit easier for you, I don't know. Let's have a look. Yeah, you just install it from the OSGFW packages. Thanks, Jürgen, for that, no doubt. But, so we have to just do a little bit more hip jumping here on Linux. Okay, now he's suggesting to do a reboot, which would be very inconvenient for me since I'm busy streaming. Let's just try that again. See if it gets a bit further than last time. Looking good. Let's see how my CPU is working for this. Not too hard. Okay, that looked better. So now we're going to go into here, we're going to run that command to build everything. Okay, so I'm just going to go up a little bit and just remove this build directory. I think I built this when my computer was still set up in Fedora. Let's get rid of that. Okay, and then we'll just follow the full steps here. So better now, it's looking better. Then we're going to run make, and I'm going to give it like J24 because I've got lots of processes. It should build quickly. Okay, that's looking good. Minus J24, and let it go. And you can see my processor should be working nice and hard now. You can see a bit of a spike there in activity. When that drops down again, we know it either failed to build or completed building successfully. Now, I'm just a bit unsure why they want us to reboot. I think it's just a sort of poor man's way of doing, just sourcing some environment variables or something like that, or maybe it's because they want QGIS to find it in the path, but I'm going to try it without rebooting. So you can see it's still building away. I think it's time to have a chocolate peanut while I wait. Almost done. Alright, and you can see the CPU is going back to calm mode again. So it built and there was no errors, which is great. And then we're going to do a sudo make install. I should have explained the PC Raster has got it's a separate library from QGIS, which has got a whole bunch of amazing processing tools in it. So this has now put some stuff in user local Python, and then it wants us to add that to the path. So I'm going to just see what my Python path is at the moment. So it's not pointing into there, it's pointing into some obscure folder. So we'll put that into my bash profile, but I'll also just run that manually quickly. And we're not going to reboot, we're going to test and see if it's working for us. Python 3. Okay, that's looking good. So we've got PC Raster installed. That was fairly painless. Luckily I got a fast CPU and a fast internet connection to get that quickly. The question is, will QGIS realize that it's there? So I'm going to just go and look in the Python console and try the same two commands here. No. Come on, not those two commands, these two commands. Okay, so that's failing, so we can start QGIS from this terminal. Let's see which QGIS we're going to get if we do that. Yeah, that's good. So if we started from the terminal where I've already set that environment variable, it'll save me needing to do reboots and things. And then we just try that same experiment. So go here. Okay, so that's looking good, and then we can run this command here. Okay, so PC Raster should in theory work. There's a new kind of strange looking toolbar here, I'm not sure what that is. Let's go and enable the PC Raster plugin. Thank you for the people who added, I can't remember who was adding those instructions. It might have been the Dutch user groups. I think Hans said they were helping to do that. Okay, so if we look in the menu of the processing toolbox, we should see PC Raster, and we should see all the PC Raster tools, and I think we're ready to hit the ground running. Let's see if I left out any steps. So I've already got the plugin installed, I've got PC Raster installed. Here he's going through all the steps to get it installed, which I had to do a different workflow, so I couldn't really follow the book exactly. And then we come to where we're going to turn our geotiff to a PC raster. So let's get that open again. In order to use the PC raster tools, we need to convert rasters to PC raster format, which is a GDAL supported format. This is necessary because PC raster is strict with raster types. Okay. So then he talks about the different types that you can have in PC raster. So Boolean, nominal, which are where they have positive or negative class values representing classes. Ordinal, where they have positive integer values representing classes. Scalar, which is where they've got floating point numbers. Directional, which is where each cell contains a compass direction. And LDD, that's a new term for me, local drain direction. Okay, I do know that. I don't know the acronym LDD, but so every slope shows the direction in which the flow would run down the slope, whereas the directional shows the which way the slope is facing. Okay, so we will convert our DEM layer to PC raster format, and PC raster go to in the processing toolbox, go to PC raster data management, convert to PC raster format. So let's go here, data manage, convert to PC raster format. I wonder why the tool has sometimes got capital letters and sometimes small letters for the names of things. It's strange. Okay, so it asks us for the input layer. And then given all that theory about the different data types, it's asking what kind of format do we want it to be in. So we're going to put it into scalar, and we're going to go save this somewhere. And it gets an extension .map. So we just call it dem.map. Alright, so now we're saving that out to a new data set. I'm going to copy my style over from the other one, see if that translates very well. And then I think we can remove the old dem. Alright, and save the project. So now we've got our data into a format that we can use for analysis with PC raster, which is great. And then we're going to do calculating the flow direction. So to do that, first we need to fill the sinks with which are any artificial depressions. I guess they could be natural as well, I don't know, but and then we're going to calculate the flow direction raster. PC raster does both in one step with the Ldd Create Tool. That's convenient. So let's find this Ldd Create Tool. So we need to look in hydrological and material transport operations. Okay, and then here's that Ldd Create Tool. And then the options we're going to set here is remove bits at edge, no. Map units, yes. Outflow depth, we leave everything pretty much at the default by the looks of things. And then the only thing we're going to do is going to make that into a new file called flow direction.map. Flow direction.map. Okay, and let's run it. Again, you can watch my CPU and see if it's working. So it looks like PC raster only works in a single core. So even though I've got 24 sort of CPU cores, I don't really get much benefit from it. It's running in a single process every time. You can see as these things are bouncing around, it's probably doing different jobs in the sequence of things it needs to do to analyze my data, find the pits, and then convert it to a direction data set, which it's probably doing now. Okay. Still busy. This is like an interesting way of just dealing with the fact that sometimes the progress bar doesn't always give you much information. You can see if I look at the progress bar, it looks like it's 100% done. But if I look at my CPU performance, you can see my CPU is still working hard. And every time the color changes basically in those bars, means another task is happening inside of the application. So I can get a much better sense of, is it still working, what's it busy with, so on. While we're waiting for it to process, I can maybe plug Hans's book one more time. The stream that I'm following, that I'm doing, is following this book by Hans van der Kwast and Kurt Menke. It's available online at a reasonable price, and if you buy the PDF version, then you'll support them even more than if you buy the dead tree one, and you'll save the environment a bit of lost trees. And yeah, it's a really lovely book, so go and look out for it at Locate Press. I think there is a link to it in my in the stream description as well. Alright, it's still processing away. Time for another chocolate peanut. I don't know how long it normally takes, but I guess with the fact that it runs on a single core, I don't really gain much from having all these CPUs, and I just got to wait it out. Normally I check my email or something while I'm doing this, but obviously live streaming, probably not polite to start working on my email in the middle of it. Somebody wants to say hello in the chat, wave your hand and tell me where you're from, or where you're tuning in from. Would be interesting to know. So let's read and see what's going to happen next after this anyway. So so it says here that Ldd Create Tool fills the sinks in the DEM and results in a local drain direction, flow direction map. If you need the full DEM, you can use the Ldd Create DEM tool. So if you want just the DEM without the flow direction. So a flow direction layer indicates the direction of flow for each pixel. Direction can be expressed as a compass direction, however we cannot store text in a raster. Compass direction can also be expressed as degrees on a circle, where north is 0 degrees and east is 90 degrees, etc. And then they go on to talk about how if you wanted to store 360 degrees, that needs more than 1 byte of storage for each pixel. So another way to do it is the D8 method, which uses discrete directions for the 8 excuse me, choking my chocolate peanut, 8 or 9 for the 8 surrounding cells. So basically it says which cell it points towards. Alright. So then he's also saying that when we styling this, we need to use a directional or circular color ramp, and that's because you want to have it that when, if you start at 0 degrees and say it's green, when you land at 360 degrees, you should be back at green again. So, looks like we're going to be doing some more Raster attribute tables. It looks like it might have finished processing because my CPU is not working so hard anymore, and we've got an interesting looking data set going on in the background here. Now, you might notice there's some artifacts like stripes through here, and I always look at those, trying to figure out how to get rid of them or what's causing them. I think in some cases the way that QGIS renders rasters also causes those artifacts because it renders them in these sort of chunks, but it could also be just some artifact in the data itself. So that looks pretty nice. Let's put our colors on the top of that. We could even make this one, is there any benefit to putting this? I don't know. We could even make this one blend the layer below it as well. I don't think there's much benefit to doing that. And if we wanted to, we could probably put that in 3D and sort of look at it from different angles and things. So that's interesting. So each of these pixels now, you'll see it's got 1 through 9 as the value. I think 9 would be, doesn't go anywhere. So if we put these into discrete colors, let's just have a look at the color ramp. Oh no, it's all just in grey. I'm looking at the street map from behind. If we put these into discrete colors like this, there each pixel color is representing one of the 9 directions, which I'm not sure which one of them will be, sort of doesn't go anywhere. Maybe it's this one here. Black. So basically it's flat or something along those lines. I'm not sure if it's one that actually represents that or which one it is. You can see some other interesting artifacts here, all these like blocks and so on. Again, I think that's because of the way QGIS chunks the data as it's rendering it to the screen using this raster rendering pipeline. But there may be some also artifacts within the Srtm data itself. Okay, so we're going to use a circular color ramp to style the flow direction layer. So we'll use a raster attribute table. So let's open our raster attribute table. So this doesn't have any coordinate reference system set. I don't know why that is. And we don't get the usual thing here for setting the raster attribute table. But we should have it in the menu. Also don't have it in the menu. So he's saying open the layer styling panel for, oh yeah, of course we have to put it first to let's see what the step is for doing that. Change the render to paletted unique values, which I have. Classify it. Right click on the flow direction in the layers panel and choose new attribute. But it's not giving it to me. Let me see if I put the Raster attribute plugin installed still. I do. So now I don't know why it's not giving me the Raster attribute table option. Let's have a think about it. What have I done wrong? Let's put it back to this one here. And put it back to paletted. We should be getting that menu option here. Click Classify to assign random. Then right click on the flow direction in the Layers panel, which I've done. There should be a menu entry here saying assign the raster attribute table. Which I'm not at all seeing. I'm going to just try to close the project and then open it again and see if anything changes. Ah, okay, I had to select the layer. Okay. Right, so we're going to go here and open the table, edit this, and we're going to set up a color table with a circular ramp. And then we must put in the numbers as per the table that it gives in the book. So that's going to involve a bit of typing away. So let's see. Okay, we need to put it in edit mode. I wonder if I can cheat and just give it orange there, and then he's got yellow. Let's go here. Yellow, and then he's got green, and he's got pink. Okay, just see, so pink now. Not pink enough, let's go more like this. And then green. I'm not following his colors exactly, but anyway, this one should be quite okay, I think. Let's have a look here, and then we're going to be a darker green here. Just not sure if we've made it into a circular ramp or not. Now let's save edits here. And then close the attribute table, and then he's doing a blend with the hill shade, which is what we did as well. So put that in multiply, turn this one off, turn that one on. Looks so interesting for some reason. Let's see. Okay, you can see a little bit of terrain changes there. Let's see what happens when you zoom out. It looks a bit like a stereo image or something. Okay. now we're going to do the styling by adding arrows, and to do this we're going to create a mesh. I'm not very experienced with meshes, so that will be fun to do. We're going to need to use the Crayfish plugin to do that though, which might give us some complications. I wonder if you still need to use the Crayfish plugin for this. I know they've been rapidly adding all their features in the Crayfish plugin into the main QGIS application. Okay, so we've installed the Crayfish plugin, and then we're going to go to Crayfish conversions, and we're going to turn that LDD to grid. Just find where it is. Processing toolbox. Crazy Fish. PC Raster Ldd to grid, so that's the one they want us to use. We take that one there. I'm going to go and save that on disk as flow underscore direction dot grid. Excuse me, more chocolate peanuts are being consumed in the background. Okay. So it's complaining about the coordinate reference system or spatial reference system, and it is something I noticed here, so I'm just going to go and set this manually. Try it again. Direction.grid. See if it does a better job of that one. Unsupported or missing spatial reference system. Okay, I think that's where I'm going to stop for tonight. We'll go figure out what that's about, and then we'll come back tomorrow and we'll carry on stream delineation. We'll do some 3D viz and some nice visualization stuff, which should be good fun. Alright, and then later we'll get to the catchment delineation, which is the part that I'm looking forward to as well. Alright, I'll go and going to go offline, go and figure out why it's complaining about this. I suspect I might need to change my raster in this LDD file to a different format, or a different coordinate reference system before I actually make it. That's it for me for now. I'm a bit too sleepy tonight to carry on, but I'll look forward to picking up again tomorrow. Thanks for watching.